So hello guys, welcome to another video. So for this video, I will be making another summary about the chapter 7 or the IP addressing in the Cisco Networking Academy. So let's get started. IPv4 network addresses, binary and decimal conversion. Binary numbers versus decimal numbers. Binary is a numbering system that consists of numbers 0 and 1 called bits. In contrast, the decimal numbering system consists of 10 digits consisting of the numbers 0 to 9. So so the in this slide it talks about the difference about the binary and the decimal. The binary only uses the 0 and 1 1 digits, 0 and 1 value, or it is also called the bits. And for the decimal, it contains the numbers from 0 to 9, which means that it can range from different values. So binary support for us to understand because host servers and network devices use binary addressing. IPv4 address structure. The IP address gives a device a unique address over a network. The subnet mask used to identify the network and host portion of an IPv4 address. The ones identify the network portion and the zeros the host portion. So the structure of a IPv4 address is the network portion and the host portion. So the first three octets with ones is the network portion, while the zeros at the end of the and the fourth value for the address is the host portion. So types of IPv4 addresses, we have public IPv4 address and private addresses. Public IPv4 addresses are addresses which are globally routed between ISP, Internet Service Provider, routers. Private addresses are not routed over the internet, so the private addresses are not like it's not shown in the or it's not routed to the internet. So the private addresses are the 10.0.0.0, the 172.16.00, 192.168.00 to 192.168.00 to 192.168.255.255. So it has all the private addresses ranges up to its maximum limit. For special user IPv4 addresses, we have the loopback addresses, the linked local addresses or automatic private IP addressing addresses, testnet addresses. IPv4 issues, the need for IPv6, depletion of IPv4 address space, Internet of Everything, the evolving Internet is becoming an Internet of Things. No longer will the only devices accessing the Internet be computers, tablets, and smartphones. The sensor-equipped Internet-ready devices of tomorrow will include everything from automobiles and biomedical devices to household appliances and natural ecosystems. Unlike IPv4, which is 32 bits, IPv6 is 128 bits. IPv4 is approximately 4.2 billion IP addresses, but IPv6 is 340 and decillion, 340 followed by 36 zeros addresses. So the IPv6 has a more range of number of addresses than the IPv4. That's why the IPv6 is somewhat better than IPv4, but still the IPv6 is not yet implemented in our to be used for now in our industry. and the IPv4 is still implemented. So types of IPv6 addresses indicates the network portion, format, IPv6 address, and prefix length. Prefix length range from 0 to 128. Typical length is /64. So there's a format for the IPv6 address. So it has the main address, which is this example, the 2001 db8a/64. So we have the /64 is the network portion, and the other is the IPv6 address. So it's so much of the same as the IPv4 address, but it somehow has um some numbers only and some periods. So this one's different. We have types of IPv6 addresses: global unicast addresses, link local unicast addresses, and unique local addresses. The global unicast addresses is similar to IPv4 public address. Unique internet routable addresses configured statically or assigned dynamically. They are in the range 2000/3 to 3 FFF for the meantime. Link local unicast addresses communicate with other IPv6 enabled devices on the same link or subnet. They are confined to a single link. They are not routable, unlike GOA. Device creates its own link local address without a TCP server. Unique local addresses, unique local unicast, almost similar to IPv4 private IP addresses used for local addresses within a site or between a limited number of sites. They are in the range of FC00/7 to FDFF/7. A link local unicast address give another IPv6 devices on the same link or subnet. SLAAC, stateless address configuration, is a method that allows a device to obtain its prefix length, default gateway address, and other information from an IPv6 router without the use of a DHCPv6 server. Using SLAAC, devices rely on the local router's ICMPv6 router advertisement messages to obtain the necessary information. IPv6 routers periodically send out ICMPv6 RA messages every 200 seconds to all IPv6 enabled devices on the network. An RA message will also be sent in response to a host sending an ICMPv6 router solicitation RS message. So SLAAC, or the dynamic configuration, is used for getting the prefix length, and default gateway address, and any other information without the DHCPv6 server. And that is how they manage to obtain the necessary information. ICMPv6 RA message is a suggestion to a device on how to obtain an IPv6 global unicast address. The ultimate decision is up to the device's operating system. So the ICMPv6 RA includes network prefix and prefix length, tells the device which network it belongs to. Default gateway address, this is an IPv6 link local address. The source IPv6 address of the RA message. DNS addresses and domain name. Addresses of DNS servers in the domain name. IPv6 multicast addresses. Assigned IPv6 multicast addresses. It has a prefix of FF00/8. Solicited node IPv6 multicast address. ICMP/v4 and ICMPv6. Host confirmation, destination of service unreachable, time exceeded, router direction, ICMPv6 router solicitation and router advertisement messages. Messaging between an IPv6 router and an IPv6 device. So RS message and the RA message. Messaging between IPv6 devices is called the neighbor solicitation neighbor advertisement message. Duplicate address detection. Testing and verification. So ping command, testing the local stack, testing connectivity to the local net, testing connectivity to remote, trace route, testing the path, round trip time, IPv4 TTL and IPv6 hop limit. Summary: explain the use of IPv6, IPv4 addresses to provide connectivity in small to medium-sized business network. Configure IPv6 addresses to provide connectivity in small to medium-sized business. Use common testing utilities to verify network connectivity. That's it for my chapter 7 summary. I hope you learned from this summary, and thank you for watching.